Hi, welcome back to a new part of this series I'm doing on converting this 1978 bus into all electric. In our last video, we got that Thunderstruck MCU wired up and we learned how to connect to it and do some programming. In this video, we're going to wire up all of these A123 battery modules into the MCU, have it recognize it so it becomes our battery management system. And then after that, we're going to go to the back of the car and install, wire up, and then configure our new charger. By the end of this video, we're going to do our first official charge of the battery pack. So stay tuned. I mentioned before that each of these 6 A123 battery modules has a measuring and balancing board on each end. And in each of these measuring and balancing boards, there is a 10-pin female connector that connects to that measuring and balancing board. And here is a 10-pin connector, and I'll have more information about this product and the pins and all that stuff later. What I was hoping for was just to create a couple little daisy chains with one of these on each end, and for example, maybe run out of my CAN bus and into one of them, and then that one automatically hooks up the other side, and then I go out of that one and into that one and into that side. You get the idea, kind of like a series daisy chain. The problem is each of the measuring and balancing boards at either end of these packs, they're not connected internally like I would have expected them to be. They're completely independent. So therefore, unfortunately, we need to chain the 5 wires that are going to come out of here, the 2 CAN bus wires, the 12-volt positive negative, and an ID reset line. All 5 of those wires have to go in one, and then into the next, into the next, into the next, each one individually. So we have to wire up all 12 of these. So I'm going to explain how we can do that right now. Back on the bench here, and thus far, I've done some work building some of these cable harnesses, and I can tell you this, yesterday I had a really frustrating time with this. It did not go well. But I've made a few mistakes and I made some adjustments, and now I think I have some momentum now and things are starting to get a little bit better for me. So for what I'm going to describe to you, hopefully will help you out greatly if you're doing anything like this. So first of all, you're going to have to buy the connectors, the plastic connectors, and the pins from Mouser Electronics. The links are in the video description. Now with these pins, like I mentioned, there's 10 pins, and if you hold it up with the clip on the top, you'll see that it goes from 1 to 10. There's a little 1 and 10 embossed in that. Keep your eyes on that. You will lose yourself if you constantly, so always double and triple check where you're putting your pins in before you actually insert them all the way. One of the problems I see with these connectors, and leave a comment if I'm wrong about this, but I don't see a way to unclip the pin once you get it seated in there and it clicks in there. There's no way to get it back. As far as the pin out diagram, I'm going to flash this up on the screen, and this is what I've been following. Now the way this works is, I mentioned before, there's 5 wires needed for these measuring and balancing boards, and they're all described in this 10-pin pinout. Now notice that half of the pins are inputs and half of them are outputs. And that's really the way A123 designed this, to be able to daisy chain these together, is by having 5 individual pins going in and then 5 individual pins to go out to the next one. And that means we don't have to do a bunch of splitting of wires and making Y connectors and things like that. As far as wire type, this is one thing that I've been struggling with. Now there's a couple ways you can do this. First of all, what I'll say is, as far as getting the wires crimped and pushed into these little pins, you probably want to stay above 20 gauge. I was able to work some 20 gauge connectors in initially, but they were really difficult to work with. So I would say 22 and 24 gauge is probably where we're settling on here. You could do it a number of different ways here. We need 5 wires to go in. So if you had 5 individual, say 22 or 24 gauge wires like these, you could do this, but you want to use nice, stiff, stranded copper conductors. None of that crappy silicone aluminum wire that they sell all over Amazon. If you're doing your CAN bus cables as a twisted pair, then you could get a stiff cable and do these by putting one end in a vise, another end in a drill, and twisting them yourself. Again, they have to be nice, stiff, stranded copper cable. That silicone wire will not work. Now the CAN bus, if you're not familiar, the reason why you twist it or shield the wire with aluminum foil is to keep the digital signal from getting polluted by RF interference. Audio wire like this microphone or XLR type patch wire is also twisted and shielded, so this makes a good digital CAN bus wire as well. What also makes a decent wire is Cat 5 or Cat 6. This is an example of one. Notice that there's 4 twisted pairs in it, 8 cores in total. This Cat 5 cable I used previously. If you notice, in my previous videos, what I did was I crimped a RJ45 end on it and used it that way. This is not going to work for this application, and I'll explain why. When you have to separate these individual conductors, for Cat 5, sometimes they end up being like 26 and 28 gauge. I think this is actually 24, but this is actually solid core 24 gauge. My problem with using solid core wire in a vehicle is that if you're separating this out and this is the only thing crimped into the pin, then the only thing holding this together would be that little 24 gauge solid core wire. If that breaks, it's over. You've got to redo it. So I don't think this cable is appropriate for that application. But if you can find Cat 5 or Cat 6 at a 22 gauge, again, copper stranded wire, I think that would be a good candidate for this application here. Another one is this security system wiring. This happens to be a 4-core 22 gauge wire, again, stranded copper conductors. And what's interesting about this is, unlike this microphone wire, it's not twisted, but it is shielded like this. Notice that we have this foil around it. And when you strip this back, there's actually separate foil going around these green and white wires and separate foil around the red and black wires. So this is commonly used, like I said, in security systems for data transfer, just like what we're doing with CAN bus here. And you've got 2 pairs in here that are shielded individually. So this would work too. What I've been doing, since I have various different types of wire and I don't have one type for everything, is I'll be probably using this 4-core wire at 22 gauge. And again, if you can find this in a 6-core at 22 gauge, not 28 gauge, this would be okay as well. But like I'm coupling these up. So I'll as much as this microphone wire as I can do, I'll use this for the CAN bus connection, and then I'll use this for the positive and negative, and maybe that 5th wire, I'll use the green, which will be the fault line or address reset wire. Okay, as far as crimping our pins on the wire, this was a huge frustration and something I needed to learn. And so now I'm going to give you my advice on this, and it's going a lot better now that I know this. Okay, so first of all, for crimping, you'll need a tool like this. And I'll provide this link to the Amazon product in the description here. This is a crimping tool for these pins. And notice that you have 3 different jaws here, and they're all based on wire size. The middle one being 20 to 22, and then this furthest one to the front, the 24 to 28 gauge. When I close the jaws here, you'll see that there's definitely a width difference in all 3 of these. So once you're done crimping that pin, it's going to be one of these widths. What I noticed was, even if I'm using 22 gauge wire, I don't want to use this middle pin for the 22 gauge. I want to still use the smallest pin for the 24 to 28 gauge. But the problem is I don't want it to chop through my wire. So kind of a not very known thing with these crimpers is this adjustment right here. And this is what I did. So this adjustment here by default was in between the plus and the minus. So see that little nub right there? It was probably 2 gears over from where I have it. So what you do is you take this screw out and you pop off the little gear thing, and you just kind of rotate this a little bit and then put it back in and put the screw back in. What I did was I rotated a little bit counterclockwise toward the minus. What that does is it makes it to where it doesn't clamp down quite as hard. And so because I'm going to be using that 24 to 28 gauge setting, but with 22 gauge wire, I don't want it to clamp down as hard, but I do want it to clamp and get that profile there. Otherwise, if I use that one, that fitting would never fit into the back of those connectors. So we always have to use this one. Okay, so how do we crimp these little pins? I'm going to take a pin off the strip here. You just kind of break it off and I'll show you what it looks like. All right, this is one of the pins here. Notice that the first part of this is square barrel, and that's what we don't want to crimp at all. We don't want this piece of the square barrel anywhere inside of our crimper. Then you've got the crimp for the wire, and then the rear, you've got the little V-shaped crimp for the insulation. What you want is you want this thing to fit inside the crimper, and you want it to be flush all the way inside there, and you want it to be flush. So here's a good example. Hopefully you can see that. See, it's flush inside there. Now notice on the other end sticking out, that square barrel is not inside the jaws. If you get that square barrel inside the jaws and you pinch it, it won't fit into the connector right. So make sure you're flush on this side, on the back side of it. Then what we could do is give it one more click, and that'll make sure it holds it in better. Okay, next what I'm going to do is take my wire, and I've already have this prepped and stripped. I'm just going to strip it a couple millimeters here, about like that. And then what you're going to do is feed it into the left side of the crimper. You want to feed it in flat against the bottom of the clip and make sure that it just bumps up against the connector on this side. Once you get it in there and it's stopped properly, then we can go ahead and crimp it all the way down. Okay, now that we have our pins all on here, I've already got a connector started with the CAN bus in wiring. Now I'm going to put the rest of my 3 conductors for the in wiring into this connector. I'm going to show you how to do that. One thing I've been doing is I got a little bit of this antioxidant compound here, and I use it kind of a little bit as like a grease for the connectors. So I'll just put a tiny bit on my fingertip and just kind of wipe a little bit on the back side of some of these pins just to make sure that they can slide in there really nice. The other thing I wanted to show you, and hopefully I can get this on the camera here, notice that on the top of that barrel, that square barrel, there's a little nub on it. There's a little ring. You see that on the top there? That bump out, if you're looking at this connector, there's a little notch on each of the pins on that right-hand side. So that little bump out on the pin goes in that notch on the right-hand side. So make sure that's on the right-hand side. So now that we've got it all prepped up and we know which side our pin's going to go on, or which orientation the pin goes, I'm going to just put this red one in, and it should slide very smoothly into the connector, probably about until you get to the end of that crimp jacket. Then, if it gets a little bound up, what you can do is take your pliers and gently grab the wire and just kind of gently push it in a little bit at a time. If you feel a tremendous amount of resistance, pull it out and use the pliers to touch up that back crimp. But you should, if you feel it pushing in and it's going pretty smoothly and the wire's not kind of bending or folding as you're trying to shove it in there, then you're probably good. And this one seems like it's good. So I'm going to shut up right now because what I want you to do is listen for this. Once you get the wire seated in there, and notice if you look at the green wire here, you have to get about a quarter of an inch of that wire inside the connector for that pin to be all the way at the top. So I'm going to push this red one in and listen for that click. Maybe it'll come out in camera here. Did you hear that? That little click means you're done. Now, the last thing I wanted to show you was, once on this middle one, I have all 10 pins inserted into there. Now, once you get all the wires inserted and they've all made a nice click and you're sure that they're all inserted, this little red piece here, notice it's pulled out. What this does is it locks all the wires in, but so you push it in once all the connectors are seated right. So if I can push it in and it goes in, that means all the connectors are seated right, and you should be able to kind of see them from in there. Okay, a little progress shot here. I think I have all of these measuring and balancing board wiring connectors all put together and plugged in. I'm not going to lie, that was a nightmare. I mean, that's what really tests whether how bad you want this. We've got this CAN bus 1 now wired here, so that's new. And then we have a positive wire on my positive block, a negative wire on my ground block, and then we have the 5th wire here, which is this ID reset wire, this blue one that I marked, and it's just kind of sitting loose here in my box. All those are going down through this connector and going around the right-hand side and going into that measuring and balancing board, out of that into that one, out of that into that one, and you get the idea. We come around here. There's a couple different patterns that I was playing around with how I would do this, but I decided on the second pattern where we go around the front here, we go in, and then around here and around, and then we end at the first battery actually. Notice I don't have that. That's the only one I don't have connected. I just wanted to show you this one thing. Now on this last 12th connector here, all I need really is the 5 incoming wires, right? Because there's nothing to daisy chain this to. That's the last one. Notice on this middle one, these middle 2 wires, this white ones, that's coming out of the CAN bus. That's on the CAN bus low and high output. Now what I did here is if you crack open this case, you'll notice those white wires go to a resistor that's looped in right here, and I've got it shrink wrapped. There's a 120 ohm resistor in there. And what the purpose of that is as a CAN bus termination resistor. So if you look at even the specs that they give you, on any CAN bus network, you have to have 2 120 ohm CAN bus termination resistors in that parallel CAN high and CAN low branch. Now one is built into the MCU on both the CAN 1 and CAN 2. Each of those CAN bus networks has one built into it. So I just needed to supply the other one. And I might have to do the same thing on the charging CAN bus as well. So I'm going to go ahead and plug that into there, and we'll move forward on getting these recognized by the MCU. Okay, so now what we want to do is see if we can get all of our measuring balancing boards to connect to our MCU so that it recognizes them. All I've done this far is that blue ID reset wire I have tied into my ground terminal right there. And then what I've done is I've gone to page 26 of the Thunderstruck manual where it starts talking about the A123 measuring and balancing board connection here. I'm going to follow these instructions right here. Now, thus far what I've done, like I said, is hooked up the ID reset wire to the ground. I've turned on my battery and I've disconnected my contactor fuses and all that because I took some bus bars out and I don't want the contactors to come on. And I've turned my KSI on so I can talk to my MCU. What we're going to do is try to talk to our MCU and tell it to recognize all 12 of our measuring and balancing boards. So the first thing they tell you to do on our MCU prompt here is to type in set MBB address or ADDR space 1 space 12. I don't know what the number 1 is, maybe that's for CAN bus 1, but the 12 is the number of measuring and balancing boards you have in your system. So if you're only using 4 modules, that's 8. If you're using 6, it's 12. You get the idea. What it says to do next is remove the ID reset wire from the ground, and that'll just be taped off in the box. And then we're going to cycle back off the power. What I'll probably do is just cycle my entire battery power off. And so both the KSI and the power to the MCU will cycle, and then we'll come back in and issue some show commands and see what the result was. Okay, so I cycled power all the way from the battery, so both the KSI and the battery power. And now what I'm going to do is I'm going to issue a command called show MBB. Oh, thank God. Okay, thank you. We have all 12 measuring and balancing boards, all with the status of OK. The next thing I want to do, let's do show cells and see if the wiring inside of the modules is all good. And it looks like it is. I mean, I haven't gone through all these numbers yet, but it looks like they're all within 3.2 something. And we have C1 all the way up to C156. So if my math is correct, 26 cell groups per module times 6, that's 156. So thank goodness, this looks like everything is looking pretty good. And you can see that a couple of the cells have little ticks next to them if they're a little bit lower than all the rest. Okay, now one final thing we need to do is issue a command called lock. What this does is it says, okay, we've got our BMS all set up, we're gonna lock it in. Well, as you can see, I was very relieved to see the fact that on my first try, I was able to get all those over 120 pins into those connectors, all are working properly, and all of our measuring balancing boards were recognized. Now that we have our measuring and balancing boards all recognized and we have our BMS configuration locked into the MCU, now we can focus on the charging. Now what I did off camera here was I put back together all my bus bars and railing all around my battery box again, and I cleaned up the wiring on the MCU. Instead of having wires spilled all over the deck lid here, everything's now going through a nice waterproof connector and going from this box to the DC command center. Now, 2 of those wires are the CAN Bus 2 network wires that are going through there. Now remember, CAN Bus 1 is dedicated to our A123 battery modules. CAN Bus 2 is for all the rest of the devices, which will just be my charger and state of charge gauge. All right, now back here in my DC command center, I've been keeping up with my documentation here, and obviously now I've got this MCU connector with all those wires that we needed there, which is my new harness here. And I've also updated the documentation on my different terminal strips and all that stuff. I suggest you do that. It's just easy to do and it'll save you a lot of time later. Well, this is my CAN Bus 2 cabling coming in, and notice that I have it going through here and then down to the charger. I also have it split right here, and it's also going into this little terminal box that you can plug a Cat 5 cable into. This Cat 5 cable is going to be for my stated charge gauge, and that's a future video. But for right now, what I have is this termination resistor, this 120 ohm little termination resistor, just kind of stuck into the terminals here on that parallel split there, just so I have that CAN bus termination. And let me go and show you now how the charger is mounted and wired. So like I had it before, I was going to use my other charger that was on my previous EV build, but it wouldn't work because it didn't have a high enough charging voltage for this new 170 volt pack. I think it topped off at about 157 volts of charging voltage, and I need more like 190 something for this new pack. So I had to buy a new one, and now that my old one's now on eBay. So this new one is made by a Chinese company called TC Chargers, which is also the same manufacturer that Elcon buys many of their chargers from. I would recommend, if you're new to this, just go ahead and buy one from Elcon. It will be the same unit, but yet they'll offer you support and service on it, whereas if you buy it direct from China, from AliExpress like I did, you won't get any service or support or even any warranty on it, most likely. So it's a little more risky, but that's what I did just to save a little bit of money. Now on these chargers, notice that I've mounted it with these steel brackets that I fabricated, and I also put little rubber isolator mounts between the steel bracket and the charger itself. So what that does is it lifts the charger off of the package tray and gives it some airflow underneath it. The way you're supposed to mount these chargers is, weirdly enough, is where the fan is at the bottom and is blowing it up, and you need room underneath there. So I gave it 3 or 4 inches of lift so that there's plenty of airflow all around it. You've got 3 different plugs on this thing. You've got this plug, which is not on the correct side for my orientation, but I still made it work. This is actually the output side, and this outputs just 2 wires just a positive and negative DC, and this is the output that will go ultimately into my main distribution box, where it then gets kind of backfed into the battery packs, which is why I need those contactors on when we begin charging. On the input side, which is over here, we have 3 wires, which is our hot, neutral, ground, or if it's 220, it's hot, hot ground. But those are our incoming wires, and that comes from my charging box. We've got our major input and output power connections done. The third one is this middle thing, and this has confounded me. This has 5 wires that you're capable of wiring to it, but for some bizarre reason, they included this massive 32-pin harness for it. And so I had a little bit of trouble with that, but let me show you what I did to fix it. So for this DC charger, and I'll flash up a picture of the model number, but I got the documentation from Elcon, even though I didn't buy it from them, because it's the same one they sell, and they do have a good description of the pinouts on this giant low voltage connector here, which is, again, for oddly enough, is a 32-pin connector here. They have, out of all those 32 pins, only 5 at most can be wired. There's an optional 2 pins that are 12 volt positive and 12 volt negative that you can wire up, and when the charger's on, this will output a 12 volt signal. So if you want to use it for like wiring some charging lights or control a device that turns on when you're charging, you can use that, but I had no use for it. Then of course you have CAN high and CAN low, our 2 CAN wires, and then this CAN ground, which is just used for shielding, which I'm just hooking up to our chassis ground. So the only really wires that I need are these 3 little wires out of a 32-pin harness. The 32-pin harness they gave me looks like this. It's got all these little things in it. It's got this latching mechanism, and it's pretty cool. The problem with it is I broke it. I mean, trying to get these pins to this waterproof connection, even just 3 of them, and I was unable to do it. I tried to take this gray piece out. I ended up breaking it. It was a mess. But here's the deal. It is a Molex plug, and the part number is clearly listed here under plug right there. What I did was I looked this up on AliExpress. Of course, Mouser sells it too. I could just buy another plug for $10 on Mouser, but the better thing to do was to look up the part number and look for a pre-wired harness on AliExpress, and guess what? That's exactly what I found. This nice pre-wired harness. I didn't have to worry about plugging any of these pins in, and even though I have 32 wires, I've just kind of taped them off, and I figured out which of the wires, based on the pin configurations that I needed, which is just these 3, which is clearly marked there, 4A, 4B, and 2F, and so I pulled these wires out, and the harness even has them all marked very nicely. And I took the ones that are for the CAN bus and I twisted them all together, and now all I have to do is graft them into the wiring that I already have and just clean it all up. So this is just another example of buy your way out of a problem. I spent an extra $10 to get a pre-wired harness, and that probably saved me an extra hour, hour and a half of trying to fight with those pins again. So it's always a good idea, just buy your way out of the problem. Okay, so I'm gonna go ahead and install this thing, and we're gonna go ahead and see if we can configure this into the MCU. All right, well, we're back in here with the laptop, ready to get into the MCU now that we have our low voltage plug wired onto our charger. But before I do that, I'm going to give you a little disclaimer here. I don't know a lot about battery charging, and this isn't my strength here. So I'm only going to give you basic information. I mean, this MCU, if you look at the manual, it supports all sorts of charging options, multiple charge profiles that can control multiple chargers based on line voltage or line current, turning them on and off or whatever. Direct DC charging, direct plug-in charging without a pilot signal, time-based charging. There's so many options. I really can't talk to you definitively about any of that. What I am going to do is give you 2 key pieces of information. What type of charger should you buy for your battery pack that works inherently with that MCU? And number 2, how to get it connected so we can basically start charging, and that's exactly what we're going to do now. So let's go. So how I selected my charger started with what chargers does the MCU support inherently. If you start at page 54 on the MCU manual, you'll see this section called Charger Support. The first one is the TSM 2500. That is Thunderstruck Motors charger that they sell. The next one would be the Elcon PFC chargers, or Elcon, whatever, and then Lear. So if you go to Thunderstruck's website, in their charging page, you'll see these represented there. So how I decided on the one that I bought starts with what's the voltage that this charger is capable of. So typically for LFP chemistry cells, you would look at a couple of different voltage numbers, okay? My old pack of modules charged as following: 3.5 volts per cell up into a certain state of charge, and then a finishing charge of 3.65 volts per cell. So if you look at what we have here, we have lithium iron phosphate, or LFP chemistry. We have two 26S modules in series, so making a total of 52S LFP pack. 52 times 3.5 would be 182 volts. If I needed to do a finishing charge of 3.65, that would be 3.65 times 52. I can't do it off the top of my head, but let's say that's close to 190 volts. So what I was looking for in a charger is capable of at least 190 volts of charging voltage. So the first one I looked at, of course, the Thunderstruck Motors 2500. If you read the specs on this, this is designed for a 144 volt kind of nominal pack. The top charging voltage was 180, which was just under what I needed. And it only had a charge current of like 13 or 15 amps, I can't remember. So it wasn't that high of an amperage charger, and the more amperage is the quicker that you can charge with. So okay, I look for the next one. Here's a TC Elcon charger. Now the one they sell here is a little bit interesting. This one has a wide voltage range. It goes from like 110 volts to 440 volts. This would be a good option if you know for a fact that you're going to probably upgrade from a low voltage system like mine to, say, maybe a Nissan Leaf that has a higher voltage of over 400. Then you could get this one and it would work either way. The big problem with this charger is at $500, it only outputs 10 amps, which would be a very slow charge for my battery pack. And then, of course, this Lear charger is a high voltage charger. This would be probably good for a Nissan Leaf or some kind of high voltage setup, but it starts at 200, so this wouldn't work at all for me. So none of the Thunderstruck options I liked. What I bought, as you know, is the Elcon TC charger. This is the documentation direct from that TC charger manufacturer. This is the 144 volt model, supports up to a charging voltage of 195 volts. So that does work for me. And an output of up to 23 amps. So it's much better amperage than their options. So that's what I used and how I decided what kind of charger I was going to buy. Okay, so now that we know what type of charger we should buy, let's go ahead and configure it so the MCU can control it. There's three things we need to do minimally to get the MCU to talk to our charger. Let's flip over and connect to our MCU here, and we're going to go to the system prompt. And then we're going to type in show config. I know I did this before on my last video. We need to pre-configure the CAN bus to make sure that it knows which network that's going to talk to the charger. Now, I had Thunderstruck do this all for me. Before I bought the MCU, I already had the A123 battery modules. I told them that I was going to use them. So they configured the CAN 1 already at the baud rate appropriate for the A123 measuring balancing boards, and that the CAN 1 was going to look for A123 measuring balancing board messaging. Similarly, I told them I would likely get a TC or an Elcon charger, even though I didn't have it at the time. And so they configured CAN 2 at a 250K baud rate, and that was going to look for onboard charger messaging. So we basically have our CAN bus network set up in the system prompt. The next thing we're going to look at is the charger type. We need to tell the MCU which charger type we're going to use. To do that, we're going to introduce a new prompt called EVCC. The EVCC prompt is specifically for configuring charger information. So I'm going to issue a show config on that one. Now what this says is I'm planning on using a J1772 plug type, so it knows how to do the pilot signal. I'm going to use an Elcon type charger. I'm going to set a match voltage of 182 volts, a max current of 23 amps, that's based on the charger setting, and a termination current of 2 amps and a termination time of 1680 minutes. I don't know what that is. They configured that for me, so we'll go with that. What I've done here is I have a basic charging profile for a single charger here of the type Elcon. Now, how do you know if Elcon's going to work? What I did was I went back to my TC charger manual. And again, this isn't the one from Elcon. This is literally from the TC charger manufacturer. On the last page, it covers the CAN bus stuff. So as you can see, what we have here is the input CAN ID of 1806 E5F4. And we have an output CAN ID of 185550 E5. If you go to the Thunderstruck manual, it'll state that the default value for an Elcon charger, just the Elcon, is E5, which is to say that it uses the CAN address 1806 E5F4 to go to the charger and the other one out of the charger. Those CAN addresses match exactly with the documentation, so I know that Elcon is the correct charger type. What they did when they set this is on the EVCC prompt, they did, and I won't do it now, but set charger Elcon. Once our charger type is set up and we've got that charging profile set up here, we're good to go here. Now, again, I'm not going to go deep into I could change parts of this charger profile. There's more settings on the charger profile that I could specify. I'm just going to leave it at this just so I could do a basic charging at that 182 volts or 3.5 volts per cell. The other thing I did was I turned on trace charging. So I think it's trace charge. You saw that in my last video when I plugged in the J1772 plug to test out the charging port. You saw that it started outputting a bunch of messages for the charger. The third thing you have to do in this thing, and we've done this already, is on that MCU prompt, what we did a few minutes ago, was to lock in our BMS settings, issuing that lock command on the MCU prompt. All I do now is plug in and I should see the charging trace and our charger should now turn on. Let's give it a shot. Okay, well, with our trace charge on, let's see what happens when we plug it in. Well, we got our fan going, we got our charge started, so it looks like it's working. All right, well, we did it, so I'm pretty happy about that. So in conclusion, with this video, we've got all of our BMS working, we got our charging working. I didn't get to the top balancing part yet, but maybe I'll do that for a future video as I figure that out. But we got a charging system working, so I'm pretty happy about that. So on our next video, I think what we're gonna do is I'm gonna show you how I incorporated this Curtis gauge, our stated charge gauge, into our VW dash cluster here, and how we can get it again wired and recognized by our MCU, so it's providing us accurate information about the state of charge of our battery pack. So stay tuned for that video. Subscribe if you haven't so you know when it comes out, and I'll talk to you later.